Right, this is very underprepared, but this is how to do the thing. Please record audio, please record audio. Okay, thank God. Because I've just recorded 2 things and I really wanted it to record audio, so basically that's it. This is how to do inequalities. So inequalities are things such as the less than or greater than sign. It doesn't matter what way these are. You don't need to know which one the greater than or equal than sign is, because theoretically whatever way around your equation is, that's the way around it should be. So if we were to just do text, it's x squared plus 2x plus 1, sure. So theoretically, all of you know that to solve that, you need to do that. So it is literally that. So in this case, well and over, it literally has one root, which is that. So x equals that. But what happens when you put this sign next to it, which is x is, oh, this is a terrible example for this. Actually no, it's a very good example. What happens so when you put that is less than 0. So if we were to draw it, drawing the curve, let's draw this. So say it does that, and then it won't cross the point. It will hit it at -1. That didn't touch. -1, and that would be at 1. So theoretically this is find x squared plus 2x plus 1 for all values which are less than 0. So as you can see here, this is technically normally written as f of x or y. So theoretically this 0 is equal to y. So whereas this, in this, where is y less than 0? Nowhere. So it's just not equal. Done. That's simple. And the other way around, if it was that way, it would be all rational values of 0. Well, every value that exists basically. So now let's hope for a better example. So let's just do x squared plus 6. Have I done it again? No. Okay. Let's do something a little bit more. There we go. X squared minus 4x plus 5 is less than 0. Yes? So if you were to do that, so when we're doing the text, we're switching to text, but it's easier. So when you're solving that, obviously you add to make -4, you solve to get 5, or you times to get 5, you add to get -4. So that theoretically means that it is x plus 5, x minus 1. Obviously you know how, because 5 plus -1 equals -4, and 5 times -1 is 5. Oh no, I've messed this up hard. I fixed it. Before you ask, I'm very qualified to be here. So in that case, x is -5 and x is -1. So obviously x is -5, x is -1. You put that on the graph here and here. So once you put it on the graph, obviously it crosses at 5, and the x points are x is -5 and x is -1. So the graph will look something like, can I use this squiggly thing? Oh, for God's sake. I shouldn't really be experimenting at this point, should I? That, and then that. That is a terrible graph. But it intersects at -5, -1, and 5, basically. So at the point where it's less than 0. So where is this less than 0? It's less than 0 here. And it's less than 0 here. So that means -5. So x is less than 0 when x is bigger than -5, x is less than -1. Why? Because in the graph obviously the x is a y point, and here obviously the y is bigger than, less than 0 in this definitive area, this area right here, and that is that point. So that is low-key all you need to know for this, I guess. It is actually all you need to know theoretically, because like you don't really have anything else in this topic, I guess, unless you want to do something harder like 2x squared plus 3x plus 2. So that'd be, it times this to give 4. I'm assuming that you don't know how to factor out these. And it adds to give 3, but I apparently don't today. And then I've chosen terrible numbers again. Okay, in this case, okay, we do a different method. We'll just do this, 4. In this case, we complete the square. So we leave as x squared plus 2x and plus 2. So that gives x plus 1 squared minus 1 plus 2, and that bit's in brackets, so that means it is 2 x plus 1 squared minus 2 plus 2 is 0. So that is, let's just change that to a that means that is also that. So then you find the solutions of this. So the solutions would be from this minus 1. So the only solution would be minus 1. So if you were to draw the graph again, that is a brilliant looking graph right there. The solution is literally that, with that being 2 and that being minus 1. So once again, for this graph, which I've chosen terrible numbers for, is impossible. Well, if it's bigger, then it's possible for every value p.